Hello friends, welcome to the second lecture of the current electricity. So in today lecture, first topic is EMF of a cell. So what is the EMF? EMF full form is electromotive force. Electromotive force. So here it is little confusing because EMF name is electromotive force, but this is not any force. So what is this? So we can say that any device any device which can continuously supply energy supply energy to flow of current to flow of electric current to flow of electric current to electric circuit to electric circuit are called electromotive force are called electromotive force. So just try to understand here. Here, EMF doesn't mean force. These are the devices that energize any electric circuit. For example, a cell, a battery, generator. Okay, these are what? These are energizing any electric circuit. So these are what? EMF. These are providing what? EMF. So what they are doing, they converting non-electrical form of energy into electrical form energy. For example, if I will talk about battery, so what it does, non-electrical form of energy is what? Chemical energy, and it converts non-electrical form of energy to electrical form of energy. That means chemical energy into electrical energy. Same way generator what it does? Generator transform mechanical form of energy into electrical form of energy. So these devices are doing what? They are converting non-electrical form of energy to electrical form of energy. So we can say that such devices means EMFs transform transform energy transform energy means non-electrical form of energy non-electrical form of energy into electrical form of energy into electrical form of energy. Correct? So here such devices, like example we will understand, like a battery it what does? Convert chemical energy into electrical energy. Convert chemical energy into electrical energy. Similarly, generator 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 convert mechanical energy into into electrical energy. So like that, many examples are possible here. So here in our topic, our focus will be on cell only. This means battery only. So EMF of a cell, we will discuss about what? EMF of a cell. EMF of a cell. So here, what is the EMF of a cell? Mathematically, we can say that what is the EMF of a cell? So EMF of a cell, in mathematically way, we can say this is the potential difference across the terminals of a cell in open circuit. We can say that the potential difference across terminal terminal of a cell is called EMF of a cell. EMF of a cell. So we will understand in more better way in coming example, but for now you can keep it in mind. This is nothing but the potential difference across terminal of a cell is called EMF of a cell. So because it is the potential difference, so its unit is also unit of EMF is what? Volt only. Unit of EMF is nothing but volt. It is nothing but volt. Volt. Correct. Now here we will discuss about the internal resistance of a cell. Internal resistance of a cell or battery. Correct. Internal resistance of cell or battery. So just consider, you know that a cell or battery, what it does? It converts chemical energy into electrical energy. So in any cell you will find there are two terminals, plus and minus. You are finding two terminals, plus and minus. And if you will open any cell or battery, you will find some chemicals inside it. Correct? Okay. So here from one terminal, let it is the positive terminal, another terminal, it is what? Negative terminal. Okay. And from one terminal, current is going to outer circuit. Correct? And then coming back to the cell. So here the chemical composition. Inside is what cell? Inside the cell is what? There is a chemical composition. Chemical composition. Now, due to this chemical composition, there one's terminal of a cell is what? Higher potential, another terminal is what? Lower potential. But when the current flows in a whole circuit, it passes through the cell also because it should complete a circuit. So when it is passing inside the cell, I'm not talking about outside the cell. When the current comes back from to the cell and it is what? Passing through the cell. So inside, due to the chemical composition, the current experience the resistance inside of the cell also. So that inside resistance is known to be as what? Internal resistance. And it is denoted as what? Small r. So you can say that the internal resistance is internal resistance. We can say that the resistance offered by the cell, resistance offered by cell due to its chemical composition so resistance offered by a cell due to its chemical composition. So it is what? Internally it is offering what? Resistance. Cell internally offering the resistance to the current that is flowing through the cell only. And this internal resistance we always connect with the EMF of a cell in series with it. So for example, if the cell EMF it is given 2 volt, that means cell ability to provide the 2 volt. But because of the internal resistance, if it is providing 1.8 volt, it means that zero point 0.2 volt is what? 0.2 volt dropped across the cell only because of its internal resistance. So here how we denote it? So here we will write like this. We will denote this as a EMF of a cell with the polarity minus and plus, and its internal resistance we connect in series. So we can say that internal resistance of a cell always connect in series with EMF of a cell. Internal resistance of a cell always connect in series with EMF of a cell, in series with EMF of a cell, EMF of a cell. Now I will try to make you understand the definition of this, what? EMF of a cell here. Potential difference across terminals of a cell is called what? EMF of a cell in open circuit. In open circuit. This one, if you have not written, then write down in open circuit. Correct? So here I have missed that in open circuit. So this one you should add that potential difference across terminal of a cell is called EMF of a cell in open circuit. Why? Because just see, if this is the cell and this is the internal resistance. Its EMF is there, internal resistance is there, and the terminals are A and B. And if open circuit will be there, it means open circuit means there will be no current flow. Open circuit means what? There will be no current flow through the circuit. It means here I is 0. Here I is 0. If I is 0, then no drop occurs across the internal resistance of a cell. So whatever the potential difference VA minus VB across the cell, that is nothing but the E, means EMF of a cell. That is nothing but the EMF of a cell. Still, if you did not understand this, later on we will understand in more better way. For now, you just keep it in mind that potential difference across terminal of a cell is called EMF of a cell in open circuit. And unit of the EMF is what? Volt. Now, next one is terminal voltage of a cell. So we will discuss about the terminal voltage of a cell in different cases. So case 1. Case 1. So in this case, for example, there is what? Cell of EMF E and its internal resistance is R, that is connected in series, and terminal points are A and B. Correct. Now we can take an example when we are charging our phone. When we are charging our phone. So what happens in the case? The outside, for example, when we are charging our phone, it get discharged and we are charging it. So that time we are connecting with the charger, and outside potential difference, definitely it is more than our battery, because battery already less potential. Okay now, so due to that, what will happen? Battery will start to get a charge from outside. The current will start to flow from outside to battery. So here, when charging condition is there, current will come from outside, means external potential difference is more than the EMF of a cell. So outside the current will come to the cell. So here it is a case of charging. You can also write it is a charging case. It is a case of charging. Correct. Now it get charged. So current will go like this. I. One thing always keep it in mind, a resistor having no its polarity. So where the current enters, that side we take the plus, where it leaves, that side we take minus. Cell having its own polarity, minus and plus, bigger line plus, smaller line minus. Now if I have to write a potential difference across A and B, so we can say that VA, first we will start with the point where we have to write the potential VA, then plus to minus means minus. Wherever we are going minus to plus, we will write plus. Plus to minus means minus, because plus to minus means we are saying it is what? Loss. So that's why minus we are writing here. So plus to minus, minus, that is E drop is happening. So E, then plus to minus again. So minus, how much here drop will happen according to the Ohm's law, I into R. So minus I into R. Then final potential we are writing till B. So minus VB equals to 0. Between any 2 points in electric circuit, if we have to write a potential difference, we always write like this only. The point we will start, we will write with plus sign VA, then we will follow the rule plus to minus, then minus to plus means plus. So here both side plus to minus, so minus E minus IR. The last point we will always write, will end with minus VB equals to 0. So here if you will write VA minus VB, then we will get E plus IR. E plus IR. It means potential difference across the terminals of the cell equals to E plus IR. Here it is what? E plus IR. Correct? Understood? Okay now. So here you can say that potential difference across the cell is more than the EMF of a cell. That's why it is a charging. Now case 2. Case 2. When is the discharging case? So here same condition we will take, only the discharging case we will take. So same cell it is, E, internal resistance R, and here current is flowing through the cell. For example, now your battery charged, okay, now it's supplying this battery charge, now battery supplying its energy to what? Whatever the circuits in the your phone, there it is supplying. So the current will supply through the battery. Correct now? No? So it is like this. So current will come back like this. Always keep it in mind. Means cell from the cell. Cell से जितना करंट बाहर जाता है उतना ही वापस आएगा. और याद रखना हमेशा सेल से जितना भी करंट बाहर जाता है वापस रिटर्न होके उतना ही करंट आता है. मैंने केवल यहाँ पे cell part को draw किया है. It doesn't mean that other parts are not there. Other parts is there, but our focus only on the cell part. That's why I'm drawing here only cell part here. Okay. Now there are two terminals, terminal A and terminal B. अब यहाँ पे दो terminal है. Now I have to write the potential difference between A and B. So as I discussed before you that how to write a potential difference between any two points in any branch of the circuit. So same way we will apply here also. So first we will denote the polarity. So see here in a resistor having its non resistor having its on polarity. So where the current enters, that side we will take what? Plus. Where it leaves, that is what? Minus. So यहाँ plus or minus हो गया. EMF of cell, this is what? Minus and plus, because already EMF of cell polarity defined. Now you will start from A. You can start from B also, you will get the same answer. For example, if I will start from A, what I will write? So एज आई टोल्ड यू पहले वी ए लिखेंगे, जहां से स्टार्ट करेंगे उसको प्लस में रखेंगे. देन वी आर गोइंग प्लस टू माइनस, देन माइनस ई, देन माइनस टू प्लस मीन्स व्हाट? आई आर. करेक्ट. देन फाइनल इज टिल बी वी हैव टू फाइंड, सो माइनस वी बी इक्वल्स टू 0. So we'll write what? VA minus VB equals to E minus IR. Correct. So here potential difference between the terminals of the cell is less than, potential difference between terminals of the cell is less than the EMF of a cell. That's why what happened? Current is supplying through cell outside. Current is supplying through cell to outside of the circuit. Correct. So this one we got that how to write a terminal voltage of a cell. One more case we will see here. एक और केस देखते हैं यहाँ पे. For example, here the same cell, if I will take case 3, means when no current flows, means when there is no current flows through the cell in open circuit. You can say in open circuit. In open circuit case. So same cell I am taking here. E and internal resistance is R, and here no current flows. So I is 0. I is what? 0 here. And if I will write the potential difference between terminals of a cell, so same way we will do here. Here I is 0, so no drop happens across the resistor. So here we will write VA plus 2 minus is minus E, then here 0, so minus 0, then minus VB equals to 0. So what we are getting? VA minus VB. VA minus VB equals to E. This is nothing but what? EMF of a cell. EMF of a cell. So as I discussed with you here, that what is the EMF of a cell? So EMF of a cell is what? Potential difference across the terminals of a cell in open circuit. The same thing I am explaining here. So I hope so all of you understood this. That EMF of a cell is nothing but the potential difference across the terminals of a cell in open circuit. Correct? So these are the three cases that defines the terminal voltages of a cell. Now our next concept is what? Kirchhoff's law. What is the Kirchhoff's law? So Kirchhoff's law, we are studying Kirchhoff's law in two parts. One is the Kirchhoff's voltage law, KVL, Kirchhoff's voltage law, Kirchhoff's voltage law, voltage law. This is also known to be as a loop rule also. Loop rule also. Correct. And second one is Kirchhoff's current law, KCL. Kirchhoff's current law. Kirchhoff's current law. Current law. This is also known to be a junction rule. This is also known to be as a junction rule. Correct? Okay. Now, what is the Kirchhoff's voltage law? One by one we will discuss here in detail. First one is what? Kirchhoff's voltage law, KVL. So Kirchhoff's voltage law is a loop rule. So in any closed circuit, for example, if I will draw any closed circuit, here resistor is there R, and here cell is there with its internal resistance, just consider E, and this register is there, let it is R1 and it is R2, and this was open, now I closed it. So in any closed circuit, you can write it as a in any closed circuit, sum of the potential gain potential gain and potential loss equals to 0, and potential loss equals to 0, equals to 0. So see here. For example, I started from here. You can start from any point. First, what you have to do, you have to define the polarity. Cell polarity already you know, shorter one is a minus, bigger one is a plus. Here we see the current is going from in this way. So where the current enter in the resistor, that side we take plus, because resistor haven't its own polarity. Where it leaves, that is minus. So here it enters, it is plus, it leaves minus. Same way here it enter plus, here minus. Correct. So you can start from here also, here also, here also, anywhere you can start a loop. It is up to you, you will get the same answer. So either you can go clockwise or anti-clockwise loop. It is up to you only. You will get the same answer. For example, if I will start clockwise and I will start from E. So if E will start, so minus to plus if I am going, so what? Plus, as I discussed with you. It will be what? Minus to plus is plus. How much? E plus E. Minus to plus plus E. Correct? Next one. Plus to minus and current is I. So plus to minus is minus, minus, and I according to Ohm's law, I into R1. Drop is I into R1. Then same way here minus y I have written, plus to minus is here. So plus to minus minus, and IR2 minus IR2 minus IR2. Same way here again, plus to minus minus IR minus IR equals to what? Loop completed here. Loop completed here. So equals to 0. So as I discussed, sum of the potential gain and loss equals to 0. So this is 0. This is nothing but what? Kirchhoff's voltage law. So here if I have to find I, so can I write it as a I equals to R1 plus R2 plus small r equals to E. If I will take this other side, then what is the I value? E divided by R1 plus R2 plus small r. Correct? So in this way, we can find the unknown terms by applying the Kirchhoff's voltage law in any closed circuit. So this was the Kirchhoff's voltage law. The second one is Kirchhoff's current law. So Kirchhoff's current law. Kirchhoff's current law is also known to be the junction rule. So at any junction in electric circuit, where branches are branches are there, means from one branch the current is coming and other branches it is dividing. So at any node, what we can define the KCL, that at any junction, it is we are saying junction. Why we saying junction? Because from here the current get divided. यहाँ से current divide हो जाता है. So at any junction of electric circuit, the sum of the incoming current equals to sum of the outgoing current, I1 and I2. So we can say here, at any junction of electric circuit, at any junction of electric circuit, at electric circuit, sum of the incoming currents, incoming current equals to sum of outgoing current, outgoing current. Correct? So here we can say I equals to incoming current only I here. So I equals to what we can write? I1 plus I2. Correct? Okay. So this is what KCL, Kirchhoff's current law. Also we say it is what? Junction rule. See here, for our understanding, we are writing it is equals to I1 plus I2. But for mathematical analysis, it can be converted into one more easier form. So that easier form, we can say that I1 plus I2 is what? Outgoing current, and I is what? Incoming current. Can I write this one as a I1 plus I2, and this I will go other side, it will be what? Plus minus I equals to 0. Correct? Now here I1 and I2 is what? Outgoing current. I is incoming. So if I is incoming, can I say minus I is outgoing? If I is incoming, plus I is incoming. So minus I, can I say outgoing current? Outgoing current. Outgoing current. Just assume it. Okay now. So we can say that sum of the outgoing current at any junction equals to 0, because it is plus of minus I only. So we can say in another way, at any junction, at any junction, sum of all outgoing currents equals to 0. Sum of all outgoing currents equals to 0. Outgoing current equals to 0. See here, this one, I have changed this form to this form because our calculation becomes easier. How? I will tell you. So just try to understand. Here, for example, I have 5 volt supply and here 5 ohm. Same way here, if it is a 10 volt supply and 2 ohm here, and same way at this point, if it is a 4 volt supply and 1 ohm. And in the question, it is asking the current in each branch. So one way that we will apply KVL. But if I have to find by Kirchhoff's current law, how can I find it? So see here you can see that current will divided in different branches. So we can say this is as a junction, and we consider the junction potential is X. Let junction potential is X. Let junction potential equals to X. So here X I will take. Now here it is as a 5 volt. Here it is a what? 5 volt. So we can divide 5 volt means plus 5 here and 0 here. So it is dividing what? 5 volt. 5 volt what? Generating what? Potential difference 5 volt. So can I write here? It is the 5 and it is a 0. Same with 10 volt means it is a 10 and 0 because it is generating the potential difference of 10 volt. Same way it is a 4 volt means here 4 and here 0. Total potential difference across it is generating what? 4 volt. Correct. So here all are common 0, 0, 0 volt. Correct. And here it is a 5 volt. Here it is a 10 volt. Here it is what? 4 volt. And here X volt I consider. And now we will apply the junction rule at X. So apply junction rule. Apply junction rule at X. So what is the junction rule? Junction rule states the sum of outgoing current. Sum of all outgoing currents equals to 0. And how to write the outgoing current or any current? How to write? We know the Ohm's law. According to Ohm's law, V equals to IR. V is what? Potential difference. So I equals to what we can write? I equals to we can write V by R means potential difference divided by resistance in that particular branch. We can find the current by this. So for example, in this branch, if I have to find, and as I discussed that sum of the all outgoing current equals to 0. So X minus 5 divided by 5 is the current in this. So X minus 5 divided by 5 is the current in this branch. Same way we can say X minus 4 divided by 1. Similarly, in this what we can say? X minus 10 divided by 2. Resistance is 2 here equals to 0. Now I can find the X value by solving this. So it is 10 LCM. Now it is 2X minus 10 and then plus 10X minus 40. And this is plus 5X minus 50 equals to 0. Now it will be 10x, 2x, 12x, 12x or 5x, 17x. So, or we can write it as a 17x equals to 40, 10, 50, 50, 50, 100. It is what? 100. Then x value is 100 by 17 volt. We got x value is 100 by 17 volt. Now, if in any branch you have to find a current, you can find out. For example, in 5 ohm resistor, if you have to find a current, so current in 5 ohm resistor is what? Potential difference is x minus 5 divided by 5. So this is how much? 100 by 17 minus 5 divided by 5. So it is what? 100 minus 17 to 5 is 80. No, 17 to 5, 85 divided by 5. It is how much? 15 by 5 into 17. It was 17. So 15 by 5 into 17. This is what? 3 by 17 ampere. 3 by 17 ampere. Hope my calculation is correct. So it is what? Correct only. Then Okay. So 3 by 17 ampere. I hope this is a correct calculation. So 3 by 17 ampere current in what? 5 ohm resistor. Same way in 2 ohm resistor if I have to find. If I have to find in what? 2 ohm resistor. So what is the current in 2 ohm resistor? Current in 2 ohm resistor. So x minus what? 10 divided by x minus 10 divided by 2. X minus 10 divided by 2. So here it is what? It is x value is what? It is already we find it 100 by 17. 100 by 70 minus 10 divided by 2. This is 100 minus 170 divided by 17 into 2. So this is what? Minus 70 by 2 into 17. It is what? Minus 35 by 17 ampere. Minus 35 by 17 ampere. What is the meaning of minus sign? As I take here, as I took already here, outgoing current, all are outgoing currents, but it is not possible. All will be outgoing current. It means here we will just change the direction. Here the current will come from here. It will not go outside. So magnitude will same, but direction we will just change here. So this definition I took for our convenience. Later on in the branch we are getting the minus current, we will just change the direction. So here we calculated by taking outgoing current, because we are getting minus, we will change the directions, and the current will be what? Current we calculated here. How much? It will be 35 by 17 ampere. 35 by 17 ampere. Same way you can calculate for 1 ohm resistor also. Okay, so I hope you understood this junction rule. Now we will go for next concept. So next concept is what? Grouping of cells. Before understanding the grouping of cells, I will discuss manipulation in electrical branch, any electrical branch. Okay, so manipulation in any electric branch of the circuit, in any electric branch of a circuit, electrical branch of a circuit, electrical branch of a circuit. What is the meaning of this manipulation? So for example, if there is a cell like this, okay, its EMF is E1, internal resistance is R1. And here another resistor is there, capital R. Here another cell is there. Let it is a E2. Okay. And this is what? R2, like this. So just see here, we can move any cell in the branch of the circuit, in the same branch of the circuit, without changing its orientation. This is the point we should note in the manipulation of electrical branch. Just you can keep it in mind. We can move any electric circuit to part, means what? Any cell. We can move any cell in the particular branch. We can move any cell, any cell, or or register, or and register position, register position in branch of a circuit, in given branch of a circuit, in given branch of a circuit, in given branch of a circuit, without changing its orientation, without changing its orientation, its orientation, correct? Okay. So now, for example, this is E1 and E2 is here. So you see here minus, plus, minus, plus. So how can I change the position? So we can write here, this one. Together we'll write minus, plus, and minus, plus. Just try to understand here. Here, I have not changed the orientation. So plus will come this side. This plus is coming this way. And then its plus is in this way. So the plus minus orientation I'm not changing. So I can write plus minus like this. And register haven't its polarity. So we can write all together without thinking much more. R1, R, and R2. Correct? R1, R, and sorry, R and R2. So E1 and E2. So we can see their polarity is the same side. So E we can write here I value will be what? I value will be total EMF of the cell is what? E1 plus E2. And total resistance is what? R1 plus R plus R2. Correct. So by doing manipulation of electric circuit, easily we can find the current in the circuit. So this is very important for shortcut methods. So I hope all of you understood how to manipulate any branch of any electric circuit. Now we will focus on what? Grouping of cells. So first one grouping is what? Series combination of cells. Series combination of cells. Combination of cells. So what is the series combination of cells? So here we will take the cells of different EMF and different internal resistance in the series combination. Let E1 R1, E2 R2, E3 R3 are connected in what? Series means one after another. Now here we can manipulate it as we have discussed now. We can write all EMF without changing its polarity like this. E1, E2, E3 and their internal resistance are what? R1, R2, R3 all together. We can write like this R1, R2 and R3. As I discussed, we can manipulate the branch E1, E2, E3, their internal resistance R1, R2 and R3. So E equivalent will become what? E1 plus E2 plus E3 and R equivalent, internal resistance equivalent will become what? R1 plus R2 plus R3. Correct? So in this way we can say that in place of these three cells, one cell of EMF E equivalent and R equivalent, its value will be E1 plus E2 plus E3 and R1 plus R2 plus R3 is the internal resistance value. R equivalent. It will be like this. You just write one note when n equal EMF cells are connected in series. If n equal EMF cells, if n equal EMF cells equal EMF of cells are connected in series then E equivalent we can say E plus E plus E means NE and R equivalent will be N into R. Correct? So this is what EMF of a cells in series combination. Same way in parallel combination. Here one thing I will explain you. Here we have discussed that cells are connected in series. Sometimes the questions are like that. If one cells are connected wrongly, means wrongly connected cells are there, then how to solve the questions of wrongly connected cells? So for example, three cells are there of equal EMF or four cells of equal EMF are there. Four cells of equal EMF connected in series. Correct? In that one cell is wrongly connected. Wrongly connected. Correct? So one cell is wrongly connected means now how many cells are correct connected? Three. So if I will write like this, four cells are there. Their internal resistance will be also same because equal EMF here. And one is wrongly connected means their polarity, his polarity is what? Different. Okay, now internal resistance is R, correct? And EMF is E, correct? So if I will manipulate this, can I write like this? E, another E, like this. And one is wrongly connected, opposite polarity it is, correct? But internal resistance will be similar like this. Now you see here, this E, this E, this E, this E, and internal resistance R. So what is the E equivalent? See here, the effect of this cell is cancelled by another cell that is wrongly connected. So only the effective EMF is these two cells only, E and E. So E equivalent is what? 2E. But R equivalent will be sum of all. R equivalent will be what? 4R. Correct? So in this way, we will understand the wrongly connected cells. How to find the EMF of what? When some wrongly connected cells are there in what? Series connections of the cell. So we can formulate this in the way, for example, if n in n cells, just we will write here, if n cells are connected in series, if n cells are connected in series, in which m cells are wrongly connected, in which if m cells are wrongly connected, wrongly connected, then E equivalent what will write? See here, E equivalent what will write? So E equivalent equals to 2E. Here it was 4, but we are writing 2E. Means one wrongly connected will reduce the another one also. If M are wrongly connected, it means it will reduce the effect of another M. That means M plus M. Total it will reduce 2M. Correct? So here we can say that it is E equivalent equals to NE minus 2ME. 2ME. See here, N is 4 and M is 1. So it is how much? 4 minus 2. It is what? 2E only. So here we can say that N minus 2M into E. But R equivalent will be same. R equivalent, it is N cells are connected. So it will be NR only. With the wrongly connected, there is no effect on R equivalent. So this is the formula. You should keep it in mind. Correct? So this is for what? Wrongly connection in the series combination. So next one is parallel combination of the cells. Parallel combination of a cells. Parallel combination of the cells. Combination of a cells. Correct? So in parallel combination, what happens? Just see here. Here, cells are there. Those are parallelly connected. It means their terminals are common. Their terminals are common. Correct? So here we will understand by taking two cells only. Here, just try to understand by taking two cells. Or three cells we will take, no problem. Okay. So here, external resistances are connected. EMF of cells is E1, E2, and E3. Internal resistance is R1, R2, and R3. Correct? So to understand it, here I will take the junction potential is X. Correct? And here if I will take the EMF or in the place of this, can I say in place of the external resistance, if I will take the zero EMF here. So what happens with this? X minus, we can say that total outgoing current, let I1, I2 and I3 from this junction is what we can say at junction rule. Apply junction rule at X. Apply junction rule at X. So according to junction rule, what can we say? X minus E1 divided by R1 plus X minus E2 divided by R2 plus X minus E3 divided by R3 equals to 0. Sum of the total outgoing current equals to 0. Okay. So here we can write X value. If we will solve this, it will be E1 by R1 plus E2 by R2 plus E3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. Correct? So in this way, we can find the E equivalent of the n cells, those are connected in parallel combination. Correct? So here we can say that E equivalent equals to E equivalent equals to E equivalent equals to E1 by R1. E equivalent equals to E1 by R1 plus E2 by R2 plus E3 by R3 divided by 1 by R1 plus 1 by R2 plus 1 by R3. This is the E equivalent. And same time, if I will write the R equivalent, because the parallel connection is there. So 1 by R equivalent equals to 1 by R1 plus 1 by R2 plus 1 by R3. So correct. In this, we can write a note. If n cells are connected in parallel combination, if n cells are connected in parallel combinations, then E equivalent equals to E and R equivalent equals to R by N. Correct now? So E equivalent will be E only and R equivalent equals to R by N. So if equal EMFs are connected, like 2 volt, 2 volt, I will connect. So E equivalent will be 2 volt only. If 4 volt, 4 volt, 4 volt, if we are connected in parallel, so E equivalent will be 4 volt only. But their R equivalent will be different, R by N. In this, one more case is there, mixed grouping. Mixed grouping. So in mixed grouping, what happens? Mixed grouping of cells. So in mixed grouping, if cells are connected in such a way so that their series and parallel both are there. For example, if n cells are connected in series combination like this, here n cells are there, n cells are there of equal EMF, so on, of equal EMF, like this, continuous, it is equal EMF. Each cells of what? Equal EMF. Here m cells, m times it is, and here n cells are there, m times it is connected. Now here, if I have to find what is the E equivalent, so E equivalent will be NE, because one time n cells are connected series NE and all are parallel, so it will be NE. And if I will ask you that what is the R equivalent, so n cells R equivalent will be NR and they are parallelly connected, so it will be NR by M. Correct? So this is the E equivalent R equivalent for mixed grouping. Sometimes in the mixed grouping questions are there that what is the maximum current in the mixed grouping. So always keep in mind that for maximum current in any mixed grouping or parallel grouping, for maximum current, one condition always we have to follow, that total internal resistance of the circuit, total internal resistance of the circuit, resistance of a circuit equals to total external resistance, total external resistance, correct? For example, I will explain this. For example, 2 volt, it is connected two times like this. 2 volt internal resistance is, you consider that 0.1 ohm, 2 volt 0.1 ohm, and here it is connected two times 2 volt 0.1 ohm and 2 volt 0.1 ohm, correct? And external resistance is let 10 ohm. Here what? 10 ohm it is. 10 ohm it is. So this 10 ohm is what? External resistance. 0.1 ohm is For each cell, it is what? Internal resistance. So for maximum current, what is the condition here? Total internal resistance means total internal resistance is here what? 0.1, 0.1, 2 times here. Okay, now we know total internal resistance is what? R equivalent is what? N R by M. N R by M. So N how many times? 2 are there? 2 times. And into 0.1. And M is what? 2 times. It is 2. So it is how much? 0.1 ohm is your internal R equivalent. And external resistance is what? 10. Correct now? External resistance is what? 10. Means here, always keep it in mind, maximum current only when will be there, then external resistance value will be 0. Here R value, it will be asked what is the condition. So R value should not be 10 ohm. In this case, it is not possible. So R value should be 0.1 ohm to get the maximum current in this case. Correct? So R value must be 0.1 ohm to get the maximum current for this circuit. Correct? So it cannot be 10 ohm. It should be what? 0.1 ohm to get the maximum current. So I hope all of you understood this. Now, the next concept is Wheatstone Bridge. So what is the Wheatstone Bridge? So Wheatstone Bridge is a combination of what? 5 resistors. So it is a combination of what? 5 resistors. Here, we will take the 5 resistors like this. Let P, Q, R, S, W. Okay. Now the point, this point is X and this point is Y. Correct? Now here, in this 5 registers combination, if I have to say that the balanced case of the Wheatstone bridge, then in that case, potential at X and Y will be same. So when potential at X, V at X and V at Y will be same, then we say that is the case of what? Balanced Wheatstone bridge. Balanced Wheatstone bridge. Wheatstone bridge. Balanced Wheatstone bridge. So what is the condition for balanced Wheatstone bridge? So for that, we will calculate the potential at X and Y, and then we will equate them, and then we will find that what should be the condition of that. So here, just consider we will connect with the supply of V volt. I will connect with the supply of what? V volt here. Correct? So here the potential will become V. Here what? It is a 0. Now apply junction rule at X. Apply junction rule at X. Rule at X. So according to junction rule, we can write X minus V divided by P plus X minus 0 divided by what? Q, and plus X minus Y divided by W equals to 0. Similarly, apply junction rule at Y. Apply junction rule at Y. Apply junction rule at Y. Correct? So when we will apply the junction rule at Y, so it will be written as Y minus V by R, Y minus V divided by R plus what? Y minus X, Y minus X divided by W plus what? Y minus 0 divided by S. Y minus 0 divided by S equals to 0. Correct? Now here, in this case, as I discussed with you, in case of balanced Wheatstone bridge, potential at X and Y same. So here this is the equation 1 and this is the equation 2. And if X equals to Y, equation 1 will become what? Here Y minus V, we can write it as a equation 1. Y minus V, this is equation 1 I am writing again because X equals to Y. So Y minus V divided by P. Then here Y by Q, or we can write minus Y by Q. And equation 2 can be written as what? Y minus V divided by R. And this one becomes 0. Here also it was 0. X, Y minus Y 0. And here also it will become 0 and it will be minus Y by S. Minus Y by S. So now this is equation A and equation B. Now if we will divide equation A and B, what we will get? We will get R by P equals to what? S by Q. S by Q. We are getting what? PS equals to QR. PS equals to QR. So here we can say when PS equals to QR, it means that is the case of what? This is the condition for balanced Wheatstone bridge. This is what? Condition of balanced Wheatstone bridge. This is what? Condition of balanced Wheatstone bridge. Balanced Wheatstone bridge. Correct. Okay. So PS equals to QR. For example, if in the case of 5 resistor combination, here if it is a 2 ohm and 5 ohm and here 10 ohm and 1 ohm, and here in the middle 2 ohm it is there, and it is asking what is the R equivalent between terminal P and Q. So here we will see that it is a 5 resistor combination. Is it balanced or not? So 2 into 5, 10, and 10 into 1, 10. It means it is a balanced. It means potential here and potential here is same, X and X. So if potential will be same, no current will flow. Potential current only flow when what? When the when there is a potential difference between the two terminals. Here the same potential, so why current will flow? If current will not flow, what is the use of this 2 ohm resistor? We will remove this. So now this circuit can be drawn like this: 2 ohm and 1 ohm, and here it is 10 ohm and what? Here 5 ohm. Correct. So here what is the R equivalent? R equivalent will be here 2 1 3 and 10 5 15. So we can write 3 into 15 divided by R1 R2 by R1 plus R2, 10 plus 3 plus 15, 3 plus 15. That is how much? 3 into 15 divided by 18, 5 by 2. This is the R equivalent, 5 by 2. Now there are different type of means Wheatstone bridge, means different way we can show the Wheatstone bridge. Always we have to check that this is the 5 registers combination or not. So here one way already we have discussed. It will be like this. This is what? Combination of 5 registers like this: P, Q, R, S, W. And another way it can be like this also. Then P, Q, then R, S, W. In this way also it can be. Okay. It can be like this also. Here registers are like this. And in this way, this is also combination of 5 registers. Here P, Q, R, S, W. Correct. This 3 ways. One more way, it is like this also. Here. So here also we can say that P, then Q, then R, S, and W. So in this way also, in different ways, we can convert in easier form, and then we can calculate based on the Wheatstone bridge condition. When it is a balanced Wheatstone bridge, directly we can remove the middle one and we can calculate. But sometimes it is the unbalanced Wheatstone bridge. So in that case, what we will do? So in case of unbalanced unbalanced Wheatstone bridge. For example, if the registers are connected, there are 5 register, but it is not balanced. Like here, if it is 10 ohm and here 5 ohm, here 2 ohm and here 4 ohm and here 1 ohm. So here you can say that 10 into 5, 50, 4 into 2, 8 ohm. It is not balanced Wheatstone bridge. So in this case, how to solve the R equivalent, how to find R equivalent? So we will connect externally 100-volt supply. You can connect any volt supply. For easier, normally we are connecting 100 volts, so our calculation will become easy. So I am connecting what 100 volt supply here. So here it is 100, here it is a 0. Now here potential I will take X and here Y. So now I apply junction rule at X and Y. Apply junction rule at X and Y. X and Y. So once you will apply the junction rule at X and Y, what you will write? Here you can write, here it is what? X minus 100 by 10. X minus 100 by 10 plus what? X minus 0 by 4. X minus 0 by 4 plus X minus Y by 1. X minus Y by 1 equals to what? 0. Next, this is equation 1. Next one is what? Apply junction rule at Y. Apply junction rule at Y. Apply junction. Apply junction rule at Y. Junction rule at Y. So when you will apply junction rule at Y, what you will write? Y minus 100 by 2. Y minus 100 by 2 plus Y minus X by 1. Y minus X by 1 plus Y minus 0 by 5. Y minus 0 by 5 equals to 0. Like this, you will have what? How many equations you will have? Two equations and two unknowns. So you will find X and Y value. Once you will get X and Y value, you can find the current also. You can find the current. Let current is coming from here I1 and I2. So what is the current? I1 you can write X by 4 and I2 you can write Y by 5. So once you will get the I1 and I2 value, so total current you can find. So here I is what? I1 plus I2. That is what? X by 4 plus X by 4 plus Y by 5. Y by 5. Once you get a total current, R equivalent is what? V by I. How much potential you applied here? Potential difference 100 volt. So here 100 divided by I. So like that you can find the R equivalent. So this is the way to solve the unbalanced Wheatstone bridge question. So I hope all of you understand the concept, whatever I discussed in today class. If any doubt is there, you can ask in comment section. Thank you.